Welcome to Study Loop.
Okay, so for this question, we need to determine the stagnation temperature first. So we have stagnation temperature T0 is equal to T1 plus V1 squared over 2Cp. We know T1 is the inlet temperature and V1 is the inlet velocity. So we know the inlet velocity in this case is very low. So therefore, we'll just simply have T0 is equal to T1, which is equal to 12 degrees Celsius. If we convert it to Kelvin, it's 285 Kelvin. So the reason why T0 is equal to T1 because if V1 is very low, that means we are basically consider V1 is approximately equal to 0. And we know 0 over 2Cp is 0. So this will give us T0 is equal to T1. So now we can determine the temperature at the throat, which is the critical temperature. So we have T asterisk, this should be here, over T0 is equal to 2 over K plus 1. So therefore T asterisk is equal to 2T0 over K plus 1. So now we can determine the critical velocity or the velocity at the throat, which is equal to the speed of sound at that location. So we have V asterisk is equal to square root KRT asterisk, which is equal to square root KR times 2T0 over K plus 1. So we know the specific heat ratio for the air is 1.4 and the gas constant for the air is 0.287 kilojoule per kilogram times Kelvin. And the stagnation temperature is 285 Kelvin. So now let's plug in back to the equation to determine the velocity at the throats, which is equal to square root 1.4 times 0.287 kilojoule per kilogram times Kelvin, and then multiply by 2 times 285 Kelvin over 1.4 plus 1. And always never forget to convert it to meter square per second square under square root. So I have 1,000 meter square per second square, and then over 1 kilojoule per kilogram. Or you can just convert 0.287 kilojoule to 287 joule. So therefore, you multiply by 1,000. So you still get the same value. Okay. And this will give us the velocity at the throats is about 309 meter per second. So now let's take a look at the options. So the correct answer should be B.